Hello and welcome to today's Defence episode of the Power of Perspective podcast with myself, Hannah, your host for today. Today I'm joined in the studio by Chris Morton, former Army Aviation Lieutenant Colonel, attack helicopter pilot and currently Global Industry Director at IFS, and Mark Healey, former Royal Navy Fleet Air Arm Commander, Air Engineer Officer and currently Head of Product Strategy within Defence at BAE Systems Digital Intelligence. Today we're going to be talking about keeping our armed forces prepared and the vital role that mission-ready available assets play in this. So Chris, Mark, welcome to the show. How are you?
Hi, Anna.
Hi, doing great.
Great, cool. So first of all, before we get into the big questions, could you introduce yourselves, maybe tell us a bit about your backgrounds and what you do in your current role? Chris, do you like to start us off?
Sure thing. So Chris Morton, and a little bit on my background first. I spent almost 21 years in the U.S. Army as an Army aviator and attack helicopter pilot. Over those 21 years, a lot of different roles, everything from tactical operational roles when I was a young officer. I had the opportunity to work in strategic roles as strategic analyst, both on the Joint Staff and also on the Army staff in the Department of Defense and the Pentagon. And my last role was teaching at universities, so had the opportunity to train and educate young cadets to become future Army officers. I've spent about 4 years, going on 4 years in the enterprise application space, doing a lot of consulting with aerospace and defense manufacturers and the like. And my current role at IFS is as a global industry director for aerospace and defense. So I spent a lot of time internally helping our organization contextualize the challenges in the aerospace and defense industry, and a lot of times with our customers, helping them understand how enterprise applications can help them in their business.
Can you tell me a little bit about what IFS does?
Yeah, sure thing. So IFS provides industrial artificial intelligence and enterprise software for organizations that service, power, and protect the world. In the aerospace and defense context, the way that I think about this is organizations that build, operate, and maintain applications for the aerospace and defense industry. We're able to provide artificial intelligence applications and enterprise software applications for those organizations. So think of everything from maintaining large commercial airliners, large military assets like Navy ships and jets, all the way down to defense manufacturers that make really sophisticated components that go in a myriad of defense applications.
Great, thank you very much. Mark, how about you?
Hi, Hannah. Hi. Yes, similar in that I am an ex-military, I'm a military veteran. Spent just best part of 34 years in the Fleet Air Arm, which is the aviation part of the Royal Navy. I was an air engineering officer for the large proportion of that. And during my tenure, I was a squadron air engineer. I was also a amphibious aircraft carrier engineer. I was a support authority for the Wildcat helicopter, and also a scrutineer for support solutions and how we support assets in service. My last role in the military was quite similar to Chris's. Again, a facet of support. I was the Chief of Staff of all aeronautical training across the MOD, be it for the Royal Navy, the Army, and the RAF. I joined BAE Systems 3.5 years ago, and since then I've very much been using my support engineering SME, support material expertise, or matter expertise, I should say. And in there, I've been shaping specific products to deliver support information knowledge management capabilities.
Great, thank you both. So if we get to the topic at hand, so what is asset availability in a defence context? Mark?
Okay, so asset availability is simply if an asset is not available, you can't use it. So to make an asset available, you need a support solution. And a support solution is something that you design into an asset at pre-concept phase.
Great, thank you. Chris, is there anything you'd like to add?
Yeah, maybe I can add kind of two ideas to it. So first is, if I back up, I like to use, sort of historical context and quotes. General Dwight Eisenhower said during World War II that many, many wars are lost because of logistics, right? So this idea of maintenance operations, and being critical to conducting any sort of military operation, right? So that kind of builds context as to kind of why this matters. But when you think about operational readiness, I think there's an important element to it that is really a little bit different. The idea of asset availability is nothing new sort of in the commercial space, right? So you think about maybe fixed assets on the manufacturing floor, or sort of, the vehicles you use that are a part of your fleet. They kind of generally have one role and mission that you use those assets to be able to perform. When I think about operational readiness in a military context, I think it's really important to overlay this idea of mission requirements, right? So, our assets or capabilities that we have in a military context aren't just about the one sort of thing that those capabilities have to do. In today's sophisticated operational environment, many of those capabilities or pieces of equipment have multiple roles. And those missions require different elements of operational readiness of that piece of equipment. And so you may have different types of missions that you have to perform with it. That's really an overlay on top of just asset availability. Well, sure, it's working, we're able to employ it, but there's a mission context that goes on top of those assets that we have to be able to consider.
Interesting. So could you give me an example or an anecdote that helps sum this up? You mentioned utility helicopters?
Yeah, so I can use utility helicopters as an example, right? So the name absolutely implies that it's got multiple roles, right? By the name of being utility helicopter. One of my operational deployments that I had as chief of current operations, we had these utility helicopters that we employed for many different roles. So you can imagine that they may have to be able to conduct what we would call an air assault operations, where you're going to fly and insert soldiers into an operational environment for them to conduct a mission, right? So we have seats installed in those utility helicopters. That very next day, or even indeed within a few hours, they may have another mission to maybe resupply that very same set of soldiers that you just put on the battlefield. Well, I want to maximize cargo space inside those. So now I have to take those seats out. I have to reconfigure that aircraft for really a completely different mission, right? So if it had the seats in, it's clearly not operational ready to perform that resupply operation. And with the seats out, in many cases, it's not ready to conduct that air assault operation for soldiers. So, that capability really has a mission dimension on top of it when we talk about operational readiness, as opposed to just kind of the idea of asset availability.
Really interesting. Okay, so how the challenge must have changed. How's it changed over the past 10 to 20 years?
Complexity of assets has increased significantly, and the requirements of our speed of decision-making on the battlefield has increased dramatically over time.
Yeah, and linking to the time element, I mean, what we found and what I've seen over the years is that because those assets are more complicated, unfortunately, the procurement costs invariably are higher for those assets. And what that fundamentally means on the ground is that we are, as the operational engineer trying to support the mission, we are trying to generate assets to deliver missions with fewer assets. Why is it more important that we do more with less? We have actually less assets. So, and less assets in a situation where the tasking levels have not changed. So asset availability and the ability to turn around those assets and the data which provides us the insights into that asset is more critical because of the time element and needing to generate those for the mission.
And I have an example that maybe will crystallize this idea, right? So you're absolutely right. Mark is spot on about complexity and time requirements. On my very first operational deployment, we had a weekly maintenance synchronization meeting that we would all physically, a bunch of us would get on helicopters and travel to our higher headquarters to be able to have a meeting about the maintenance status of our aircraft. Right now, I was a young officer, totally conscious that I was also in a learning environment. I had a really, really great commander at the time that was helping us understand maintenance operations, because he used to say, maintenance is operations, by the way. It's not just something you do to support operations. And so, we were flying to go have these meetings. On my last operational deployment, simply not an opportunity. It's just not something we would do. The speed of warfare was a lot different, very dynamic environment. We just never would have even contemplated doing that. So, over time, and the way we understood the maintenance status of our aircraft was very digital, and it was, synchronized. So yeah, so time has definitely changed, even my time in service. And so, no longer were the days where I'm going to go get on a helicopter and fly to a meeting with a bunch of papers and books in hand to be able to talk to people about the maintenance status of our aircraft.
And if you don't maintain that level of availability, what's the consequences?
Well, it's a bit of a no-brainer for me, Chris, is if you don't make something available, you can't do the mission, and fundamentally, have you not failed?
Yeah, exactly. Yeah,
You got to make it available for the operators to use it.
yeah. And in most cases, it's simply not an option.
Okay, so it seems to me that it's all about understanding what assets you have, what state those assets are in, and therefore what you can do with those assets, kind of summarized very briefly.
Yeah, so we talk about data, we talk about data silos. We had the segue of about what the operational engineer needs to do, and that's what I was. And fundamentally, my raison d'etre was, as an operational engineer, we need to generate assets for the mission. And to do that, you need to have the available resources, and those resources are dependent on the support solution. To do this efficiently, we need to understand our assets' behaviors, and ultimately the data, be it in the design phase, tells us through modeling, and then the data associated with the operation of the asset in service, we can convert into information. And that information can be performance information, it could be business information, it could be management information. But ultimately, without that data, without that insight and knowledge to convert that data into information, you can't optimize the support solution. By having that data, you can then have focused interventions of improving the availability of that asset over time. And, I had an example where a particular manufacturer had an asset which its availability wasn't as good as it could be. And so it's focused in on understanding what was affecting its availability. And what happened in this scenario is they analysed the data that was being drawn, and it was historical data as well. And they identified, of the sort of 25,000 equipments that were fitted to the airframe, they identified 100 or so key equipments which were affecting its availability. And then they had an investment decision. Do I make those equipments more reliable, i.e. don't have to do any work to them? That's expensive, we have to modify. Do we try and improve how we maintain them? Do we improve the training of the individual, or is that tooling, or is it just access and maintainability? Or is it more cost effective to have more spares available at the point of use or available around the globe? And fundamentally, what they decided to do was a mixture of those things, and primarily was modifying those equipments so they were more reliable. And they did achieve improved availability, and realised what they fundamentally wanted was availability for that particular asset at a particular level, which then met the requirements of a customer, and the customer then bought into that particular asset.
Really good example of how it works in reality. So, Chris, have you got anything you'd like to add about the dependence on data of these particular solutions?
Yeah, and this idea of data silos is a challenge. It's certainly not unique to the defense industry, by the way. But when it comes to defense forces, I think there's some ideas that we should really think about that have unique challenges. And I want to talk about this in a way to sort of, bring context to it. But defense forces don't operate in vacuums, right? Increasingly, military operations require combined operations. So, work with different kinds of elements, infantry and aviation, or infantry and artillery, right? You have to be able to conduct operations in a joint environment where you have naval operations combined with Army operations, or, Air Force, right? So we operate those environments where services are working together. I would even push it further. In most contexts, we like to operate in a multinational in a way, right? So we have nations operating with each other. So don't think of it necessarily as data silos traditionally, but goodness gracious, we have to be interoperable in many different ways, right? And so these silos that exist within those different sort of echelons that I mentioned are problematic, because every single one of those echelons or forces, creates systems and processes to be able to maintain their assets, right? Unfortunately, you have to think more holistically. You have to move to a place where we can understand the operational capability of a strike package or a task force. As we put these elements together, right? I can't conduct a mission unless I have a contextual understanding of the operational readiness of that entire force, right? Of the helicopters with the ships, right? Of the pieces of equipment like the tanks that are operating in context in conjunction with other forces. So you can't just think about it in that context. So data silos, I would even say systems and process silos, just a result of the nature of military operations. And data doesn't equal information. I want to be very clear about that. And it's going to go to a problem I'm going to talk about in a minute. I used to teach cadets, college students, and I would tell them, look, data is almost useless to me. You have to apply analysis to make information for me to consume as a decision maker and a commander. Mm-hmm. And so we have to be able to apply operational systems that don't just spit out data, right? We are inundated with data in an operational environment. We have to provide information in order to make decisions. I actually think it's a challenge with democratization of data these days, right? So, in the past, when you have this information about operational readiness at a unit, when I would fly to the other base to talk about the maintenance of my helicopters, I could provide you contextual information about that aircraft, right? Because I'm giving my analysis based on the maintenance. I'm not just spitting out data to you. In this day of democratization of data, there's a real danger that this data floats up echelons and they draw the wrong conclusions. So I think it's really important when we think about data silos is not just breaking down those silos so that we have data across those different echelons, but contextualizing the data so that it's providing valuable information for commanders to make decisions. So that's what I say about data silos and some of the challenges that we face today.
Okay, so the data side of it's interesting. That's obviously a more modern problem. So how was asset availability managed historically?
Today you'd say not well. But, let me just kind of build the sort of evolution of it, right? Really, preventive maintenance was carried the day, right? So think of everything is on a schedule. I am going to conduct this sort of maintenance on this piece of equipment, whether it needs it or not, right? So, it's not predictive. It's not based on the condition. You really bring it in to do maintenance, and you may not have an idea of the condition of that particular piece of equipment. You're going to find out because you're going to pull it apart. And on this day or at this time or at this many flight hours or whatever, you're going to conduct maintenance, right? So that's the old way of doing it. Paper-driven, manual, schedule-based, but it created a very deliberate system for us to plan off of, right? I know when this aircraft is going to go into maintenance. I know how many flight hours I'm going to spend on it, or I know how much time this ship has been at sea. I know I have to be able to conduct this sort of maintenance on it. That has really evolved in the second stage, I think, is really condition-based maintenance, right? Okay. This particular piece of equipment has had certain sorts of conditions applied to it. I'm gathering some kind of data perhaps off of it, or I'm logging it, right? So, aircraft flew, over the ocean so many flight hours. So the engines obviously may need certain kinds of maintenance. There's a set of conditions that have been applied. That's a little more effective, right? Because I'm not on a strict schedule, but there's a condition that says, look, you should probably conduct maintenance on this. And where we're really going is this idea of predictive maintenance, right? So I know you asked me about where we were, but I want to build in context. Predictive maintenance is, look, these things have happened to this piece of equipment, and I can apply advanced machine learning algorithms to this asset to say, you're going to need to conduct maintenance. You're going to need to replace it because the system understands the conditions that it's operated under and then is able to apply algorithms to predict when you need to conduct maintenance so it doesn't fail. Failing absolutely increases operational risk. When you're talking about operating in a combined and joint operations environment, you have lots of assets integrated together that we have to be able to synchronize from a maintenance perspective. So, in the old days, I got to fit all those schedules together, right? Like on a Gantt chart, I've got to line up the jigsaw puzzle pieces together. That's kind of the way we had to do things. It's slow. It doesn't provide a lot of information. It doesn't have a lot of context. And that's the way we used to conduct maintenance. And we're doing a better job today. I think there's tons of opportunities to apply advanced technologies as the underpinning system to allow you to operate in a more effective way.
We conducted maintenance in paper logs, and the air crew would come down. They would codify the faults, and the logs would provide information, which then would be all posted, and they would pore over the reason for the fault. And the rectification of the fault, and they would make decisions on whether or not we needed to modify the aircraft to improve its availability, or we needed to have more inventory on the shelf available at the front line. Today we're in a situation where, we still have predictive we have scheduled and unscheduled horizons, and we have now fitted sensors on aircraft and you have sensors on ships as well, where ultimately that data comes off and it's fed into an algorithm or into some sort of application, which then provides you trend data and tells you whether or not actually it's looking like it's going to fail or not. But there's always that human element in this, and whilst we are promoting AI, and AI might give us insights, from my perspective, AI, ML, those applications that provide us insight is another tool, and it's for that engineering planner alongside the mission planner to decide when we do the maintenance, where we position the space, the spares. Because what we don't want to happen is, for argument's sake, we've got a squadron of aircraft, and this could, a quite extreme event where that unhuman element has now told you that actually you need to change all engines on all aircraft because actually they're all reached a point. That would be very inefficient with your workforce, and equally you could have been in a position where your workforce isn't doing anything because nothing is coming up as being scheduled activity. So there's a human element in this still to strike the balance, but AI, ML, etc., are just a new tool in your ability to deliver your support solution. Yeah.
So how does the defence sector get a handle on all of this and tackle operational agility head on?
From my perspective, and I'm speaking like a bit of a taxpayer to a certain degree, from a UK MOD perspective, the MOD's got a lot of tools that it's already got, and I don't think it exploits them sufficiently. So you've got maintenance management capabilities, you've got enterprise resource planning tools, you've got LSARs, logistics analysis records, and ideally what they really need to do is to integrate those capability in such a way that actually spurts out the insights that they need to maintain levels of availability or improved availability. And that's through creating performance information, business information, and the management information and associated analytics. And ultimately, the benefits for doing that is you have enhanced insights. You create something once, and it can be exploited across support applications. You're reducing repetitive work. You're not having to input data into one application that does one type of support, be it, for argument's sake, safety management or hazard management or maintenance management. You could integrate it into that one application, and if you've got the right information model within your integration capability, it feeds applications that hang off it. You can benefit from having data primacy. You understand where the primal data sits across your integrated capability. You'll have a live picture. Fundamentally, it ultimately should streamline operations because you're not, as I said, feeding data from one application to another, and also it enables controlled collaboration across your support chain. Would be the benefits. And I think key to this, moving forward, to promote interoperability and interchangeability, and also to think about the workforce, because these capabilities and these evolving capabilities, a lot of them approach it in a way that it's a revolutionary change, and doctrinal and processes that a particular unit might be using suddenly has to change. But actually, those integration capabilities where you could integrate existing applications alongside new applications is key. But to promote that in the longer term, I think those standards are key in that space. So the interface between the integration capability and the application is a known entity, and that known entity be it the scope of data, the types of data you're expecting, and the endpoints. People talk about APIs. APIs are something you're familiar with, Hannah, and people think, oh, you can connect your data really quick. You can connect your applications quite quickly, but that's not an interface. An interface is where you know the type of data you're expecting, you know where to look in that application, and you equally know how to farm that data across your integrated capability. And I think that is key for the defence sector. But it's not just the defence sector. This support solutions, the ability to exploit the principles of integrated logistics support or integrated lifecycle support or product support is applicable to the rail industry, is applicable to the oil and gas industry, etc. So, this is a broad space. So it's not, I don't think, the question's about defence, but I think it's applicable to a broader market.
Chris, anything you'd like to add?
Yeah, just quickly, when I get asked this question, what should defense forces be thinking about when it comes to this? I think there's three must-haves. The first is you have to integrate data and information, right? We don't operate in a disconnected way. We talked about technology silos. We don't operate on the battlefield in data silos. Why the heck would we build them in our logistics operations? Makes absolutely no sense. So from hitting on what you said, Mark, absolutely have to integrate. Second is we've got to get to predictive maintenance. If you're conducting maintenance and logistics operations in a non-predictive way, you are not going to achieve the speed that the battlefield requires today. It's just not going to happen. You're going to be left behind by somebody else who is. So as it relates to operational availability or operational readiness, predictive maintenance is 100% a requirement on the modern battlefield. The third idea is when it comes to your enterprise applications that underpin your ability to conduct maintenance operations, you have to approach this the same way that we approach large capability acquisition, this idea of modular open system architecture. I buy a new helicopter, I'm going to have it for 40 years. I have a new radio system that comes out. I don't want to have to rip out the whole guts of the helicopter to put in this new advanced technology. In the enterprise space, it comes in the form of composability. You want to have an enterprise architecture that fundamentally is composable, that allows you to integrate and work with other applications to work together seamlessly. So three must-haves. You've got to integrate, you've got to have predictive maintenance, and you have to operate in a composable nature.
So everything we've spoken about so far, it sounds like it's a very technical problem, but I'm guessing there's a really big people element to this as well.
Yeah, one of the things when I think of it, absolutely, when I think about people in U.S. Special Operations Command, they have these things called Special Operations Forces truths, soft truths as they're known. So think about like just 5 laws, right? And one of the laws is that humans are more important than hardware. And that absolutely applies not just in the hardware space, but in the enterprise application space. You're thinking about software. Humans are fundamentally more important. Military structures are built on this hierarchical ideas of control, right? Very disciplined, very in-depth systems and processes. And those require human beings. And so whilst you can have, very sophisticated underpinnings, you have people that make decisions fundamentally. And so, people are more important than hardware. Our military structure is built upon things like command authority and understanding things operationally. So people are absolutely the center of everything. And the last one, and I'm going to hit on this one more time because I think it's super critical when you think about this, is you have to turn data into information for people to make decisions, right? At the end of the day, I've been in situations where I have to make a decision, but I'm completely overwhelmed with data. Right? That analysis that we're able to overlay on top of that to provide information, like not just, hey, this particular maintenance component has failed 50 times over the last, whatever. Okay, fine. Tell me what do I do with that? Oh, you should then conduct maintenance on this in 2 weeks to make sure that you mitigate the risk of a fit. That's an example of information you have to be able to provide. So, humans are absolutely more important. They have centricity in the military decision-making process. And as long as we can turn information or data into information for people to make decisions, I think that's where we need to go.
Yeah. So from my perspective, and I completely agree with what Chris has just said. But I'm thinking of also in the context of developing the technology. So what is important from my perspective is you only develop these capabilities if you got leadership buy-in, because leadership provides a resource, and they need to champion the cause to enable you to create the technology so you can you can sell it to your customers. But they also, by championing the cause, they need to understand what that capability is doing and what we're trying to achieve. I think both from an industry perspective and a customer perspective, you need to nurture the team. I don't think it's effective to revolutionize their procedures and how they operate. I think evolving is healthier. Bringing them along is key to the successful delivery of and exploiting these capabilities. That means that their doctrine may have to change. Their processes ideally could stay the same or need to be changed, but ultimately they need to be educated in small steps to improve the availability, if we go back to what this is all about. And then ultimately, for all this to happen, you need to enable the team. And so you need to create that integrated data environment which we've touched upon. We need to have the ability to use new and existing components, clearly educate on the new. You need to think about the other functions in this space. So you need to contract for information. You need to make sure the information is available. And I recognise the IP. You need to protect IP, but you need to protect IP in a way that it doesn't stifle the performance, the management, and the business information that's needed in order for you to optimise availability through your support solution.
Thank you both. That's been a really interesting discussion. Final question. What would you like people to take away from this chat?
Yeah, so I know we covered a lot of ground. If I could summarize it, I think military operations continue to evolve. They're getting even more complex, and decisions have to happen much faster. You have to be able to operate in that new contextual environment where things are complicated and you got to be quick. And you got to do it across echelons, right? Both in a combined arms way, in joint operations, and frankly, in a multinational role. You have to be able to not only make very quick decisions in a complex environment across up echelons and also across all the way through in a multinational environment. And you have to do it effectively. So you have to access these tools to be able to help you do that. And as we mentioned, at the end of the day, humans are play a central role. So if I was going to kind of summarize, 3 things, that would be it. Deal with the new environment that we're in, apply applications that help you do that across echelons, and keep human beings at the center of your operations.
Great. Thank you. Mark, what would it be for you?
I'm going to use a phrase I've used before, which is one that's used by many as support engineer. Design for support the design, and ultimately that is availability is a function of reliability, maintainability, and sustainability. Information is key, but information comes from data. You need to understand your data. What do you need? Where does it come from? You need to provide access to that data, and then what the key enablers are. When you've got you've created this information, you need to have suitably qualified and experienced people to understand what that information is telling you. They need to be equally have the knowledge. They also need to be empowered to react to that information in order to maintain or increase that level of availability.
Great. Thank you so much to Chris and to Mark for taking us into the detail of asset availability and what that looks like for mission readiness. Thank you both.
Thanks.
Thank you.